So welcome to everyone. Welcome to Dr. Rajesh Biogenesis Chemistry Academy. So myself Dr. Rajesh Kumar Pavaku. So today we are going to start your organic syllabus and organic major and most important topic IUPAC nomenclature. So why I am starting IUPAC nomenclature? Because especially if you go through stereochemistry and if you go through any other organic related chapters, and in that particular cases everywhere IUPAC nomenclature will play a important role. So each and every name of a organic molecule with the name of common as well as IUPAC, everything will be discussed complete detail, and even if any complicated areas comes regarding stereochemistry, so going with the RS nomenclature is it, so there is a possibility of asking questions with them. Okay, so that's why IUPAC nomenclature will be very important for your organic concepts. Okay, let's start with the key areas of IUPAC nomenclature. So mostly IUPAC nomenclature related to naming of an organic compound. So generally if you want to give a name of any organic molecule, okay, so I can use like this: naming of a organic molecule. Naming of a organic molecule is nomenclature. Nomenclature is nothing but how to give naming of a organic molecule. So this is actually giving a name of an organic molecule, that's what is called nomenclature. So naming of organic molecule is called nomenclature. Generally these nomenclatures are two types. So first we can say common name. Common name of a organic molecule. Second one is IUPAC name. So right parallelly it will be most helpful for you. So if you listen clearly only single time, you can understand complete concept without any questionnaires regarding to the concepts. Okay, you will not get any kind of question. So organic molecules ni manam rendu vidaluga naming istamama. First entante common name antamu, second one entante IUPAC name. So what is common name? First I would like to explain what is common name, and next I will explain IUPAC name. What is common name? Common names ante enti? Common name is nothing but giving name of a organic molecule by using a source name. So from where it is extracted and what is the history of that molecule. So this is also called trivial name. Trivial name means previous history, source from where it is extracted. Adi ekkadi nunchi manam extract chesam, dani yokka previous history enti. Okay, so వీటిని మనం ఏంటంటే కామన్ నేమ్స్ అంటాం. కామన్ నేమ్స్ ఆర్ నాన్ సిస్టమాటిక్ నేమ్స్. దే ఆర్ కాల్డ్ నాన్ సిస్టమాటిక్ నేమ్స్. అంటే ఒక సిస్టమాటిక్ ఆర్డర్లో ఉండవమ్మా, అండ్ దే ఆర్ లిమిటెడ్ ఇన్ నెంబర్. లిమిటెడ్ ఇన్ నెంబర్ అంటే ప్రతి మాలిక్యూల్ కూడా మనం IUPAC నామెన్క్లేచర్ ఇచ్చినట్టుగా కామన్ నేమ్స్ మనం ఇవ్వలేము. ఓకే, సో లిమిటెడ్ ఇన్ నెంబర్, వీ కెన్ గివ్ కామన్ నేమ్ ఫర్ ఓన్లీ ఫ్యూ మాలిక్యూల్స్. కామన్ నేమ్స్ మే బి రిపీటెడ్ ఫర్ మల్టిపుల్ మాలిక్యూల్స్. Okay, that's why, so don't think about how to write a common name for each and every molecule. If any molecule have a tendency to write common name, that you need to prepare. Okay, so maximum cases lo common name may be repeat for multiple molecules. Konni molecules ki entante common name repeat avutu untundi. Some molecule there is no common name, directly we can write its corresponding IUPAC name. So common names sometimes in your examination based on your conceptual knowledge, especially alkanes to nitroalkane, sometimes in middle they will ask. It is also helpful for stereochemistry. So that's why in detail common names, IUPAC names I will explain for given molecule. So that's why every time try to concentrate clearly. Okay, so best example I will show some selective molecules I am taking, and what is its common name. See, this is called generally formic acid. Formic acid. So this is also called formicus. ఫార్మికస్ నుంచి ఇది ఎక్స్ట్రాక్ట్ చేస్తారమ్మా. సో దిస్ ఈస్ రెడ్ యాండ్స్. ఇనిషియలీ ఫార్మిక్ యాసిడ్స్ని రెడ్ యాండ్స్ నుంచి ఎక్స్ట్రాక్ట్ చేస్తారు. సో అందుకే దాని నేమ్ ఏంటంటే, ఇది రెడ్ యాండ్స్ నుంచి ఎక్స్ట్రాక్ట్ చేశారు కాబట్టి దీనికి ఫార్మిక్ యాసిడ్ అనే నేమ్ వచ్చిందనమాట. సో ఐ కెన్ సే దట్ ఫార్మిక్ యాసిడ్ కమ్స్ ఫ్రమ్ ఫార్మికస్, రెడ్ యాండ్స్. స్ట్రింగ్స్ ఆఫ్ రెడ్ యాండ్స్ క్యారీ ఫార్మిక్ యాసిడ్. రెడ్ యాండ్స్ స్ట్రింగ్స్లో ఫార్మిక్ యాసిడ్ ఉంటుంది, అందుకే ఈ ఫార్మిక్ యాసిడ్ అనే నేమ్ ఈ మాలిక్యూల్కి ఇవ్వబడింది. ఓకే, నెక్స్ట్ ఇఫ్ యూ గో త్రూ CH3 C double bond OH, this is called acetic acid. This is acetic acid. This is known generally sour taste. Acetum, given as acetum. ఈ అసిటిక్ యాసిడ్ జనరల్లీ గివెన్ ఫ్రమ్ అసిటమ్. సో జనరల్లీ ఇట్ ఈస్ బిలాంగ్స్ టు సోర్ ఇన్ టేస్ట్. సోర్ టేస్ట్ ఉండడం వల్ల ఈ మాలిక్యూల్కి నేమ్ ఏంటంటే అసిటమ్ అనే వాడు వచ్చింది. అసిటమ్ నుంచి దీనికి అసిటిక్ యాసిడ్ అనే నేమ్ కంప్లీట్గా కామన్ నేమ్గా మనం డిరైవ్ చేసాం. ఓకే, సో దట్ ఈస్ అసిటిక్ యాసిడ్. నౌ గో త్రూ వన్ మోర్ ఎగ్జాంపుల్. CH3CH2 C double bond OH. ఇయర్ 3 కార్బన్స్ ఉన్నాయమ్మా. ఈ 3 కార్బన్స్ ఉంటే ప్రోపియోనిక్ యాసిడ్. Propionic acid is called first fat. First fat in newborn baby is nothing but first propionic acid. Okay, so this propionic acid name is given based on this first fat. Okay, so protus pyote, mostly it is comes from protus pyote, nothing but first fat. That's why this P word protus pyote is given to propionic acid. Okay, next, if I take 4 carbon consisting skeleton, here 4 carbons are present. These 4 carbons are generally given as butyric acid. This is called butyric acid. Generally comes from butter. So it is coming from butter. That's why name given as a butyric acid. 4 carbon acid. 1, 2, 3, 4. That's why it is called butyric acid. Butyric acid commonly derived from butter. That's why name given as a butyric acid. Okay. And this is well-known molecule. NH2 C double bond O NH2. This is called urea. It is comes from urine, human urine. It is extracted. That's why given as urea. Aminomethanamide. Okay. Even I can take a dicarboxylic acid. This is called malic acid. See here, this is C double bond OH. So this is called malic acid. Name given as a malic acid. So why it is given as malic acid? It is extracted from malus fruits. Malus fruits నుంచి extract చేశారమ్మా. That's why it is called malic acid. And generally it is belongs to apple. Apple is an example of malus fruits. So ఈ molecule కి malic acid అనే నేమ్ కామన్ నేమ్. ఎందుకు ఈ molecule కి malic acid అనే నేమ్ కామన్? బికాస్ ఈ యాసిడ్ అనేది కామన్గా malus fruits లో ఉంటుంది. బెస్ట్ ఎగ్జాంపుల్ ఫర్ malus fruit is apple. Okay, and this is well known acid CH2 C double bond OH. And here also C double bond OH. Then I am giving one carboxylic acid and one more is OH. So this is commonly known as citric acid. Citric acid. Citric acid comes from citrus fruits. It is comes from citrus fruits, lemon, orange, etc. Okay. So mostly it is comes from orange, lemon. That's why name given as a citric acid comes from citrus fruits. So they are called common names. Okay, common names ఏంటంటే common names are comes from previous history. ఆ పర్టికులర్ మాలిక్యూల్ యొక్క పేరెంట్ ఏంటి, వాటి యొక్క ప్రీవియస్ హిస్టరీ ఏంటి, ఎక్కడి నుంచి ఎక్స్ట్రాక్ట్ చేయబడింది, అండ్ ఆ పర్టికులర్ కాంపోజిషన్స్కి మెయిన్గా ఉండేటువంటి క్యారెక్టర్స్ ఏంటి, ఆ క్యారెక్టర్స్ కానీ కాంపోజిషన్స్లో కానీ జనరలీ వీ కెన్ గివ్ నేమ్ యాజ్ కామన్ నేమ్. సో కామన్ నేమ్స్ అంటే కొన్ని మాలిక్యూల్స్కి మల్టిపుల్ టైమ్స్ ఇట్ విల్ బి రిపీటెడ్. Some molecules can have more than one common name will be available. So that's why few organic molecules common names you need to remember. కొన్ని molecules కి మీరు common names గుర్తుపెట్టుకోవాలి. ఎందుకంటే మీకు HNMR లో కానీ IR లో కానీ అండ్ ఈవెన్ UV లో కానీ అండ్ ఈవెన్ ఇఫ్ యూ కంపేర్ విత్ ఏ స్టీరియో ఐసోమర్స్ ఇన్ స్టీరియోకెమిస్ట్రీ. స్టీరియోకెమిస్ట్రీ కూడా సో సమ్ టైమ్స్ దే విల్ ఆస్క్ హౌ మెనీ నెంబర్ ఆఫ్ స్టీరియో ఐసోమర్స్ ఆర్ ఎక్స్పెక్టెడ్ ఫర్ ఏ గివెన్ స్టీరియో ఐసోమర్ ఆఫ్ ఏ మాలిక్యూల్. ఒక మాలిక్యూల్ ఇచ్చి ఆ మాలిక్యూల్కి ఎన్ని స్టీరియోసమర్స్ పాసిబుల్ అని అడుగుతాడు అండ్ ఆ మాలిక్యూల్ యొక్క కామన్ నేమ్ అడుగుతాడు ఇనిషియల్గా ఎగ్జామ్లో. ఓకే, సమ్ మాలిక్యూల్. సో ఫైండ్ ది నెంబర్ ఆఫ్ స్టీరియోసమర్స్ గివెన్ బై టాటారిక్ యాసిడ్, glutaric acid, like that. So means it is commonly comes from common names only. So that's why don't neglect common names. Okay, so I will make a short revision by using this one. See, generally we need to put heading as a nomenclature directly given as a nomenclature, IUPAC nomenclature. But first I would like to start what is nomenclature. Nomenclature ఏంటంటే ఒక ఆర్గానిక్ మాలిక్యూల్స్కి నేమ్స్ ఇవ్వడానికి ఉపయోగించేటువంటి జనరల్ రూల్. ఓకే, నేమింగ్ ఆఫ్ ఆర్గానిక్ మాలిక్యూల్ ఇస్ కాల్డ్ nomenclature. Write parallelగా రాసుకుంటామా, it will be very easy to understand. Single time if you listen you can attempt all kind of questions, right? So nomenclature generally two types, common name, IUPAC name. First we are discussing common name. Common name అంటే ఏంటి? కామన్ నేమ్ అంటే ఒక ఆర్గానిక్ మాలిక్యూల్ ఎక్కడి నుంచి మనం ఎక్స్ట్రాక్ట్ చేసాము, దాని ప్రీవియస్ హిస్టరీ ఏంటి. సో ఎవ్రీథింగ్ విల్ బి గివెన్ హియర్. ఫ్యూ ఎగ్జాంపుల్స్ ఐ ఎక్స్ప్లెయిన్. ఫార్మిక్ యాసిడ్, అసిటిక్ యాసిడ్, then followed by propionic acid or propanoic acid, then butyric acid, urea, malic acid and citric acid. Okay, so while entering into the actual concept, I will give many common names for any selected organic functional group. Okay, next. Now I am going to start most important one, IUPAC names. IUPAC names, also called IUPAC nomenclature. What is IUPAC nomenclature? How this IUPAC nomenclature helps to identify an organic molecule with a name. Okay, so IUPAC nomenclature is completely systematic nomenclature. Systematic nomenclature. IUPAC nomenclature introduced in 1892, completely established in 1919. ఇది 1892లో ఇంట్రడ్యూస్ చేశారమ్మా. 1892లో ఇంట్రడ్యూస్ చేశారు. 1892 నుంచి కంప్లీట్లీ ఎస్టాబ్లిష్ కావడానికి ఆల్మోస్ట్ ఆల్ 1919 వరకు కంప్లీట్ హిస్టరీ మేకప్ చేసి విత్ ప్రాపర్ రూల్స్ దే ఆర్ కంప్లీట్లీ ఎస్టాబ్లిషెస్. ఇంట్రడ్యూస్డ్ ఇన్ 1892, established in 1919. This number you need to remember. Okay, so IUPAC nomenclature completely, if you compare for any molecule, so they are unlimited. They are unlimited in number. Unlimited in number. So generally IUPAC nomenclature, you need to say IUPAC. IUPAC అనే వర్డ్స్ తోటి దీన్ని సపరేట్ చేయాలి. డోంట్ సే IUPAC. IUPAC అనకూడదు. Generally you can say IUPAC. Okay, and every molecule, if I take any single molecule, okay, so every single molecule have its own name. That name cannot be repeated for any other molecule. Okay, so that's why it is called one word names. IUPAC is also called one word name. Why it is a one word name? Because every single molecule carry only one name according to rules. IUPAC rules prakaram ఒక మాలిక్యూల్కి ఏదైనా ఒక నేమ్ ఫిక్స్ అయింది అనుకోండి, ఆ నేమ్ అనేది వేరే మాలిక్యూల్కి ఎట్టి పరిస్థితుల్లో కూడా రిపీట్ కాకూడదు. దట్ ఈస్ ద ఫస్ట్ కేస్. సో ఐ కెన్ సే ఇట్ ఈస్ ఎ వన్ వర్డ్ నేమ్. ఎవ్రీ సింగిల్ మాలిక్యూల్ హ్యావింగ్ ఇట్స్ ఓన్ నేమ్. ఇట్ ఈస్ జనరల్లీ రిప్రజెంటెడ్ యాజ్ IUPAC. దీన్ని జనరల్గా IUPAC అని అనకూడదమ్మా, దీన్ని మనం IUPAC అనే అనాలి. అది కూడా రూల్. ఓకే, సో జనరల్లీ వాట్ ఈస్ IUPAC ఇండికేట్స్? ఇంటర్నేషనల్ యూనియన్ ప్యూర్ అండ్ అప్లైడ్ కెమిస్ట్రీ. ఓకే, సో దే ఆర్ కాల్డ్ కంప్లీట్లీ సిస్టమాటిక్ నేమ్. So it is introduced in 1892, established in 1919. Okay, so it is generally present in Geneva, Switzerland. So committee held in 1892 and it is completely established in Geneva, Switzerland. ఇది కూడా మీకు ఎగ్జామినేషన్లో ఉపయోగపడుతుంది. And finally IUPAC name generally we can classify into three words. Three common words ఉంటాయమ్మా. Generally IUPAC is belongs to prefix, then root word, then suffix. Okay, prefix, root word and suffix. So generally prefix is further classified into two types. It is primary prefix. Next is secondary prefix. Primary prefix, then secondary prefix. And here suffix also generally classified into two types. Now I can say primary suffix, next is secondary suffix. You remember these names. Okay, so this is called primary prefix, PP. This is secondary prefix. It is word root also called root word. And see, this is primary suffix, this is secondary suffix. Total 5 terms are there. So IUPAC name of any molecule depends on 5 terms. IUPAC is a mixture of 5 words. I can say primary prefix, secondary prefix, then root word, primary suffix, then finally secondary suffix. So it is a mixture of 5 words. You remember these 5 words here. IUPAC is a mixture of 5 words: primary prefix, secondary prefix, root word, primary suffix and secondary suffix. Okay, so keep concentrating on the topic. Some points you need to add while framing the any key point. Okay, so here in this case IUPAC nomenclature or systematic nomenclature introduced in 1892, established in 1919. Then IUPAC nomenclature unlimited. As number of organic molecule increases, then IUPAC names also keep on increases. So they are unlimited in number generally represented as IUPAC. Every single molecule have its own name, and it is also called one word name. It is there in Geneva, Switzerland. IUPAC is a mixture of 3 words, further converted to 5 words. Okay, so mostly you remember this 5: primary prefix, secondary prefix, root word, and primary suffix, and completely secondary suffix. So here start with S only. Okay, see, this is PP prefix, SS, nothing but suffix. So while entering into the concept, once if you complete 2 to 3 classes, then only I will explain some selective examples by taking multiple choice questions. Okay, so right now you need to know the concept, so that's why slowly I am starting. So then once if you know the concept clearly, then automatically you can write the name very easily. Right, now I am discussing about the 5 words. Later on I will show how to give the name of a molecule. So first one, that is called primary prefix. Primary prefix. Okay, first one is primary prefix. What is primary prefix? Where it will be helpful? How it is represented? PP, it is represented as PP. Primary prefix, it is completely tells about presence of ring, presence of cyclic ring. Ante given molecule, whether it is carry any ring or not, that is explained by primary prefix. Ante ichina molecule ring unda leda dani matram idi explain chestundamma. Okay, example teeskondi. Primary prefix, suppose see if I take this one, this is called cyclo. Now I can write propane. Here cyclopropane, cyclo is a primary prefix. Cyclo is a primary prefix for this one. Suppose if I take this one, this is called cyclobutane. Cyclobutane, here cyclo what is common. So most probably remember primary prefix applicable only for rings. Okay, suppose if I take 6 membered with double bond, so here I can write cyclohexene. No need to worry how I am writing, you focus only on cyclo words. Suppose if I write any double bonds are present here now. Okay, so I can say cyclo, here multiple double bonds are present, hexa, I can start from here. 1, 2, 3, 4, and this is 5, and this is 6. 1, 4, cyclohexa, 1, 4, diene. Cyclohexa, 1, 4, diene. That is the name. Okay, many rings you can apply here like this. Any ring, it is a, suppose if 2 rings are present, bicyclo, tricyclo, like that. Okay, so wherever ring is present, so there we are going to use the word cyclo. So cyclo is a primary prefix applicable only for rings. Suppose if rings are not present, you try to ignore primary prefix. That is simple. Okay, next. Go through secondary prefix. Next is secondary prefix. It is represented by SP. Secondary prefix, SP. What is secondary prefix? Secondary prefix completely tells about presence of substitution, whether any substitution is present or not, whether there is a presence of any locants or not. That is explained by secondary prefix. Okay, this secondary prefix also explain second grade functional group. Second grade functional group. So whether there is a presence of any second grade functional group in the form of substitution, that is explained by secondary prefix. Okay, so here I am writing a group, left column I am writing a group, and right column I am writing a secondary prefix for that group. So 2 columns you need to maintain. So this secondary prefix you need to remember clearly. Okay, suppose see if I write CS3, so this is generally given name as methyl, and if I write CH2 CS3, then this is given as ethyl. You need to remember. So this is CS3 and here one more CS3 now. If this group is present, use the word isopropyl. Isopropyl. Okay, and if any carbon having 3 methyl groups here, this is CS3 and here one more CS3. This is called tertiary butyl. this is a tertiary butyl. Like this, you need to remember this secondary prefixes. If this group is appeared anywhere, so it is sometimes they will give in the form of Me. It is given in the form of Et. It is given in the form of isopropyl. It is given in the form of TBU, like that. If these groups are appeared anywhere, you need to name like this: methyl, ethyl, isopropyl. This is called tertiary butyl for this one. So what is this bond indicates? This bond indicates it is attaches to parent chain. Remember this point. Okay. So you need to practice these names clearly. Don't neglect nomenclature, because everywhere it will follows. Even in your second chapter, starting from alkane, alkene, alkyne. Okay. So sometimes they will give only reactant molecule in the form of IUPAC name. Sometimes they will give reactant directly. Answer will be in IUPAC nomenclature. So that's why directly as well as indirectly nomenclature will play a biggest role. That's why you should be very strong in nomenclature. It will be helpful both for stereochemistry as well as even reactions also. Okay. So 2 columns I am maintaining. Left column belongs to what is the type of group. Then right column belongs to secondary prefix. How to name this particular substitution if it is present in a parent chain. This bond indicates that it is connected to parent chain. So after selecting parent chain, if these groups are present somewhere else, we need to use these words clearly. Right. Next, see, if I take a molecule with CH2 unit like this, it is present mostly in cyclic rings. CH2, 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 cyclopropane CH2. This is called methylene. Methylene. And if carbon-carbon double bond is present on CH2, if this is sigma and this is pi bond, these two are sigma bonds. So this is called methylidene. This is methylidene. And if carbon-carbon triple bond is present, normally what does this bond indicates? Triple bond. It is connected to parent chain. It is also connected to parent chain. These two are present within the ring. Okay. So this is called methylidine. End with YNE. It is end with ene. It is methylidine. Okay. Suppose if any double bond is present, carbon-carbon double bond. So here I can write ethylidene. Ethylidene. And if I write any triple bond over here, carbon-carbon triple bond I am writing. This is also represented as ethylidine. I am ending with ine. YNE. See this? End with ene, ine, and it is end with ine. Okay. So if I take a carbon-carbon double bond and double bond is inside. Now this bond is indicates that it is attaches to parent chain. Attaches to parent chain. So this one we need to end like this. This is ethinyl. Ethinyl. Okay. So suppose if triple bond is present, one of the hydrogen replaced by parent chain. Now here hydrogen is not present, CH2 is not there, CH, and here one hydrogen replaces, attaches to parent chain. This is generally represented as ethinyl. Every time remember, by removing one of the hydrogen, if you connect it to parent chain or if it is exists as a substitution, E is replaced by YL. Suppose here one hydrogen is there, ethene. Remove that E, write down YL. And here also same. Okay. Suppose CH3 carbon outside double bond is present. Carbon attaches to double bond and this carbon carry 2 methyls. This is generally represented as isopropylidene. This is called isopropylidene. And same molecule I can write like this by removing one of the hydrogen, put double bond between them, and if I write this substitution outside. And this is called isopropynyl. Remember, I am not disturbing the double bond. Outside whatever hydrogen is present, that hydrogen I removed and I connected to parent chain. This is called isopropynyl. Propynyl. EYL. Okay. And if I take any carbon-carbon double bond, see. So, if this carbon attaches to any double bond, this is called saturate. This is generally represented as allyl. Allyl, and if you give numbering, so it is connected to parent chain, and this is 1, 2, 3. Second carbon having double bond, so I can say 2-propynyl. 2-propynyl. This is called 2-propynyl. Right. Focus on giving names. Remember, It is attaches to triple bonded carbon. Now it is attaches to double bonded carbon. It is attaches to only one carbon. See, 2 bonds attaches to parent chain. Only one bond attaches to parent chain. When one bond is attaches to parent chain, I removed hydrogen and I connected to parent chain. You remember this technique. And here 2 bonds attaches to parent chain. Okay. So first thing is no need to confuse. Don't be tense by watching these molecules. Only thing first you remember. Try to practice it. Slowly you can remember these all examples. Okay. With practice you can remember. Try to learn clearly. Single attempt is sufficient. Single time if you listen, don't go for attempting any miscellaneous examples. Okay. So whatever content I explain on the day, same day if you prepare, up to that content it will be clear. You can attempt up to there. Whatever concepts are there, that all concepts you can attempt clearly. So this and this both are not same. It is present in cyclic 3-member ring. It is present outside of a double bond. Okay. Now here this is sigma and this is pi bond. It is sigma, sigma. That's why it is methylene. It is methylidine. It is methylidine, triple bond. Ene means double bond. Ine means triple bond. Right. Now, so I am putting a double bond over here now. This is CH3 carbon carbon double bond, and here hydrogen is removed and it is connected. And if I give numbering 1, 2, 3, first carbon carry double bond, so I can say this is 1 propenyl. 1 propenyl. First carbon carry double bond, that's why 1. 3 carbons are present, and here it is ENYL, propenyl. Okay, so this particular group I will show later. The one double bond is present, that name I will explain as a vinyl. Okay, so here if I take this one, CH3, CH2 carbon carbon double bond, next here it is CH2 and here one more CH2. If I take this one, 1, 2, 3, 4, this is called homoallyl. Homoallyl. Group name is homoallyl. It is also represented as 1, 2, 3. So 3, total number of carbons are but, ENYL, butynyl. Okay, this is called homoallyl. Here one more example I explain. Just go through this. This is called allyl. This one I am saying. This is allyl and this is ethenyl. It is also called vinyl. You remember this one, vinyl. Find the number of signals in allyl, homoallyl, propargyl, like that they will ask. So on that time it will be most helpful. It will be helpful for stereochemistry, HNMR and even chemical reactions. So we are uploading separately. Nomenclature separate videos will be there. So it is belongs to actually your second chapter. There it was given as nomenclature. Okay. Now, if I take carbon carbon triple bond, okay, and here triple bond attaches to CH2. This is called propargyl group. Propargyl. And one more way of representing 1, 2, 3. Second carbon carry triple bond. So why I given as 1 here? Why not this as 1? Because see, this is connected to parent chain. Parent chain first carbon always taken as 1. So this is 1, 2, 3. So now second carbon carry triple bond, I can say 2. It is 2 propine. This is called 2 propine. Otherwise see, here one hydrogen is removed, and if you remove that hydrogen, say YL, 2 propenyl. So 2 molecules are there. 1 propenyl, here see propenyl. It is EN. If you concentrate here, it is only double bond. And right now it is triple bond, YN. If you go through this one, here 2 propenyl I given. See in this one. Here also 2 propenyl. But see, it is ends with EN. Okay? But here it is ends with YN. There is a difference. Then this is well known. If any halogen is present, so write down halo. X is nothing but halogens. Fluoro, chloro, bromo, iodo, like that. Okay? So if any hydroxy is there, so use hydroxy. OH is hydroxy. Then if I take SH, this is sulfonyl, used as sulfonyl. SH is sulfonyl. Okay? Suppose if I write OR, OR is called alkoxy. Alkoxy, ether. or nothing but either alkoxy. Then if I take C double bond OH, this is called formyl, also represented as oxo, formyl oxo. Also sometimes they will also mention as aldo, formyl oxo aldo. Okay, so if I take C double bond OR, this is nothing but keto. Sometimes they can also use oxo. This is ketone and this is aldehyde. Okay, suppose if I write C double bond OH, this is hydroxy carbonyl, carboxylic acid as a secondary prefix named as hydroxycarbonyl. Okay, so here if I take C double bond O, OR, ester, I can write alkoxycarbonyl. Then if I take any halogen, C double bond OX, this is called halocarbonyl. And here I can take a anhydrate, C double bond O, like this. So this is called acetoxy or acetyl oxy. Like that we can give many names. You need to remember these names, no other alternative. You need to practice once and twice. Definitely it will be settled down in your mind very easily. It is heart of organic chemistry. Nomenclature will play a big role. Don't take that much negligence. By watching the molecule, you are in a position to say the name. Formyl, sometime oxo, aldo, aldehyde. Now this is keto, oxo, hydroxycarbonyl, alkoxycarbonyl, halocarbonyl. This is called acetoxy, also called acetyl oxy. Okay, next. So if I take C double bond O, NH2, this is carbamyl, not carbyl amine, it is carbamyl. Suppose if any alkyl group is present, alkyl carbamyl, dialkyl carbamyl, if two substituents are present here. Okay, suppose if I take CN, this is called cyno, and if I write NC, this is isocyno, and if I take NO2, NO2 is nitro, use nitro, and if it is NO is nitroso, it is nitroso. You remember this name. Carbamyl, it is a primary amide used in Hoffman degradation reaction. Suppose if one of the hydrogen replaced with alkyl, alkyl carbamyl. If two alkyl groups are present, dialkyl carbamyl, like that. Okay, so cyno, isocyno, nitro, nitroso. Suppose see if I write NH2 group, this is called amine, also called amino, 2 amino, 3 amino, like that we can use. Now suppose if benzene ring is present directly, benzene directly connected here, so this is named as phenyl, it is named as phenyl. And see, if benzene connected to carbon, if this carbon is connected, so this is called benzyl. So this is a symbol I am writing. Remember, this symbol indicates disconnection symbol. If this carbon attaches to parent chain, that is benzyl. This is phenyl, don't say benzyl. This is phenyl and this is benzyl. Now here two carbons are connected here now. So this carbon having CH2. Now this carbon having hydrogen, two bonds are connected here now. This bond and this bond. So this is called benzol. This is benzol. Okay. Now if I take a carbon having no substitutions here with hydrogen, every hydrogen replaced by substitution like this. So this carbon is called benzo. Use the word benzo. Okay. So if benzene attaches to oxygen and it is further attaches to oxygen like this. So this is benzyl attaches to oxygen. So I can say benzyl oxy. This is called benzyl oxy, like that. Benzyl oxy derivative, etc. Okay. And finally see, we can take a molecule where bromine attaches to C double bond O. So this is clearly looks like a haloformyl, C double bond O, like this. This is called bromoformyl. That is secondary prefixes. So all possible secondary prefixes are given with multiple fragments. These all are fragments which you need to remember. Okay, just make a revision because content is going on. So I explained what is common name and IUPAC name. So try to remember all common names of formic acid, acetic acid. Okay, then later on protospiote, propionic acid, butyric acid, urea, urine, malic acid, one more is citric acid. So about IUPAC nomenclature, they are systematic nomenclatures introduced in 1892, established in 1919, and if you want to give nomenclature, we need to follow some rules. So here key point is this one, IUPAC, where it is present, Geneva, Switzerland. Sometimes suddenly they will ask in PCB, where IUPAC nomenclature is introduced, where it is, committee, where it is held, Geneva, Switzerland. IUPAC name is a mixture of 5 words. What is IUPAC? International Union Pure and Applied Chemistry. It is a mixture of 5 words, primary prefix, secondary prefix, root word, suffix, primary suffix and secondary suffix. So right now we discussed what is primary prefix. Primary prefix explain about ring. If any ring is present, use primary prefix cyclo. If I use the word cyclo, it is a primary prefix. Suppose if there is no ring, don't apply primary prefixes. Then go for secondary prefixes. It tells about second grade functional group. It also tells about the presence of substitution or locants. So you remember this methyl, ethyl, isopropyl and tertiary butyl. Then followed by methylene. This part is very, very important because completely hydrocarbons with double bonds and triple bonds explained. Methylene, methylidine, methylidine, ethylidine, ethylidine. Then this is very, very important one, vinyl, also called ethinyl. Ethinyl, it is also ethinyl, but see, triple bond. Isopropylidine, isopropenyl. Then here see, it is looks like allyl. Yes, it is allyl. Double bond attaches to CH2, allyl. Then, so here one propenyl, so everything I given, and this is well known for you, I think so. Halogen, hydroxy, thiol, alkoxy, ether, it is aldehyde. Okay, it is ketone. It is carboxylic acid, ends with hydroxycarbonyl, alkoxycarbonyl, halocarbonyl, acetoxy, etc. So these are the all possibilities. Carbamyl, cyano, isocyano, nitro, nitroso, amino, phenyl, everything is okay. So that is about secondary prefix. Next, root word. Third one is root word. Root word. Root word also called word root. What it explains? So it explains number of atoms in a parent chain. Okay. So how many number of atoms present in a parent chain? Number of atoms in a parent chain is nothing but a word root. How many atoms? That may be carbon, may not be carbon. Most of the people, they will think that parent chain carry 5 carbons, pentane, 6 carbon, hexane. That is not correct. So maybe parent chain carry carbon or any other heteroatom. We can take down as a atoms. So it may be carbon or any other atom. How many are present in parent chain? That should be taken as a root word. Okay. So generally, if one atom is present, generally you people learn with carbon. I am also writing with carbon. So C1 is nothing but meth. C2 is nothing but eth. C3 is nothing but prop. And C4 is but. C5 well known, pent. C6 hex. Okay. So C7 is hept. C8 well known, oct. C9 known. Okay. So C10, this is dec, decane. C level, undec. Okay. C12 dodec. Okay. So like the tridec, tetradec, pentadec, octadec. 19, C19 is nonadec. This is nonadec. C20 is ecos. Suppose C21 is there. Here I can say hen ecosane or enicos. C22 doecos. So C23 triecos, tetraecos, pentaecos, nonaecos. Then finally you will get C30. C30 is nothing but triacantane. Otherwise you can write triacant. Ane is nothing but alkane, triacant. Okay. So then C40, that is tetraacant, pentaacant. Then C60 is nothing but Buckminster fullerene. Many names are there. Fullerene, also called buckyball. It is also called buckyball, also called saccharine. Okay. So Buckminster fullerene, then buckyball, soccer ball, And see, this is also represented as, this is hexa account, represented as hexa account. So later on C70 hepta account, octa account, C80, C90 nona account. Then finally see, if you keep on writing here, you will get 100. 100 is nothing but, this is called hect. Hect. Hect means 100. Okay. Suppose if it is 200. 200 is here. This is do hect. This is do hect. So 300 tri hect. Hect, not hept, it is hect. 300, that is trihect. Like that, tetrahect, pentahect, octahect, nonahect. Finally you will write 1000. 1000 is nothing but kili. Now 2000. If I write 2000, this is daily. Daily. 3000. 3000 is trili. So like that, 4000, 5000. And if I take 9000, 9000 is nonali. Okay. So this is nonali. Total 9999 up to that much number of carbons in a parent chain, we can write nomenclature. Okay, so these all are well known, I think so, up to 20. Decane, undec, dodec, tridec, tetradec, up to 20 ecos. 21 henicos, doicos, triicos, tetraicos. 30 is triaccount. 40 is tetraccount, pentaaccount. 60 is very important one is 60. Hexa account also called Buckminster Fullerene, also called buckyball, soccer ball, hexa account, etc. 100 is nothing but, see, 70 hepta account, octa account, 80 nona account. Then straightforwardly 100. 100 nothing but hect. 100 is hect. Then dihect, trihect, 1000 is kili. Now here this li word is important. Li. Here see li, li. Li mostly belongs to thousands. Okay. So kiliane, if it is alkane. Suppose see, if it is a single bond, end with ane. Ane, kiliane. If it is alkane, kiliane. If it is double bond, end with ene. Kiliene, like that. Okay, kili, daily, trili, tetrali, nonali, etc. So total 9999 we can write. That is root word. Right. So root word is over. Next, fourth one. Fourth one is primary suffix. Primary suffix, that is PS. Okay, it tells about whether there is a presence of saturate or unsaturated between the carbon. Whether there is a presence of saturation or unsaturation. Between carbons, whether there is a presence of saturation or unsaturation, that is explained by primary suffix. Suppose if carbon-carbon single bond is present, end with AN. If double bond is present, end with EN. If carbon-carbon triple bond is present, end with IN. So these are the most common repeating units in organic chemistry for a carbon-carbon multiple bonds. So if any molecule, whether it is a saturate or unsaturated, expressed by primary suffix. Okay. So if primary suffix tells between two carbons, if any double bond is present, try to write En. Don't write ENE. ENE is different, En is different. If in a given hydrocarbon part, if carbon-carbon carries single bond, end with An. If carbon-carbon carry double bond, end with En. If triple bond is present, end with In. So that is secondary suffix. Then last one. Suffix, very important one. SS. Secondary suffix. Primary suffix is over. Next is secondary suffix. So secondary suffix explain about principal functional group present in a given molecule. Principal functional group. So what is a principal functional group? Also called riding functional group, dominant functional group. Okay. So always if you want to select any parent chain, so it is depends upon the secondary suffix only. Parent chain completely explained based on secondary suffix only. Riding functional group also called dominating functional group, also called principal functional group. So principal functional group is explained by secondary suffix. Okay. So now here I am writing, left side I am writing functional group. So two columns you need to maintain, functional groups. Then here I am writing secondary suffix. Okay, so first one I am using a hydrocarbon. Remember, so what are hydrocarbons? I can take alkane, I can take alkene, I can take alkyne, alkyne, cycloalkane, alkadiene, alkadiene. Alkadiene. Okay, so these all are called hydrocarbons. When hydrocarbon is present, we need to end with E. Any hydrocarbon, benzene, even you can take alkane, alkene, cycloalkane, alkadiene, alkatriene, alkanols even. So alkanols nothing but alcohol. But if it is only hydrocarbon, on that time name end with E. Okay, suppose if it is OH, if it is alcohol, it is end with OL. Okay, now next functional group. Suppose if it is SH is there, SH end with thiol. If it is OR, so what is OR indicates? So here it is alkoxy alkane, ether, alkoxy alkane. Suppose if it is aldehyde, C double bond OH, it is end with Al. If it is C double bond O, this one, this is ketone, ketone end with one. This is called ketone. SH is nothing but thiol. SH end with thiol. Now this is called alkoxy alkane, aldehyde, formaldehyde, and this is ketone. Suppose if I write C double bond OH, C double bond OH end with oic acid, oic acid, methanoic acid, ethanoic acid, like that, end with oic acid. Suppose if it is ester, O double bond OR, so this is end with O8, O8, methyl methanoate, ethyl ethanoate, like that. Functional groups I am writing. Suppose if it is C double bond O X, so it is end with OYL halide, methanyl halide. Okay, so after that if I write any C double bond O, C double bond O, this is called anhydride, end with anhydride, methanoic anhydride, ethanoic anhydride, like that. And if it is C double bond O NH2, C double bond O NH2, this is called amide. Okay, so if it is NH2, so this is amine. Primary amine, secondary amines are there, so all are functional isomers. So I can say NH2 is belongs to amines here. OL halide, anhydride, amide, then what is this? Amine. Okay, so if I take carbon nitrogen triple bond, cyno, cyno generally represented as nitrile. This is nitrile. Okay, so if it is NC, isocyano, isocyanate, then generally it is represented as carbyl amine. Carbyl amine. Suppose if there is a presence of NO2, okay, so it is represented as nitroalkane. Nitroalkane, then ONO, alkyl nitrite. This is alkyl nitrite, nitrite. And finally see, if I write SO3H, sulfonic acid, this is belongs to sulfonic acid. So there is a way of writing secondary suffixes of individual functional groups. These names you need to remember, no other alternative. So by watching the molecule, you are in a position to identify their secondary suffixes. Okay, in short, one more time I will explain. See this, especially functional groups only. So if you see this primary suffix tells about presence of single bond, double bond, and triple bond. If it is a double bond, in, don't write ENE. If between two carbons, if double bond is present, write down EN. If triple bond is present, write down IN. If single bond is present, write down AN. This tells about presence of saturation or unsaturation. Saturation means completely single bond, unsaturation means maybe double bond or triple bond. Clear? Next. Secondary suffix, it tells about presence of principal functional group. What type of functional group is present in that case? Okay. So if all hydrocarbons are present, any hydrocarbon, only carbon hydrogen is present, try to end name with E. If it is OH, end with OL. Next, these are the all functional groups I given. Thiol, alkoxyalkane, aldehyde nothing but Al, and this is called ketone, oic acid, O8, ester is O8, OYL halide, and this is anhydride, amide, amine, Nitrile, don't say cyno. Cyno is a secondary prefix. Now this is called carbylamine, nitro, alkyl nitride, and this is sulfonic acid. So these are the available functional groups here now. Okay, now I am explaining few examples where you need to apply these 5 terms at a time for a given molecule. Okay, see one example. If you understand this, it will be very easy for you. See, I am giving this molecule CS3. Now we know IUPAC is mixture of 5 words: primary prefix, secondary prefix, root word, primary suffix, secondary suffix. In this one there is no ring, there is no substitution. Root word. Root word means how many carbons are present? Eth, 2 carbons only. Primary suffix tells about presence of saturate or unsaturated. Between 2 carbons single bond is present, that's why I am writing AN. Okay, and here secondary suffix, it is a hydrocarbon end with E. So now see, name is ethane. No need to learn separately. If you know clearly, you can write the answer. Now if I write carbon-carbon double bond, no primary prefix, no secondary prefix, root word is eth. Carbon-carbon double bond is there, ene, hydrocarbon. So now name is ethene, like that. Suppose if triple bond is present, carbon-carbon triple bond. Now I can write root word eth, there is a triple bond, that is yn, then it is E. So I can say ethine, like that. Okay, one more example I will show. CS3, CH2, then this is OH. Okay, so there is no primary prefix, there is no secondary prefix here, because no substitution, no ring. Then finally I can use root word, then primary suffix you need to check, secondary suffix. So what is the root word here? Root word is generally represented as eth. Now primary suffix, between 2 carbons only single bond, AN, and this is end with OL. So what is the name of this molecule? This is called ethanol. It is ethanol. Okay, so if I take any aldehyde, see this, CH3, C double bond OH. So no primary prefix, no secondary prefix here, and root word. If you start from here, 1, 2, 3, total number of carbons are 3, prop. And between 2 carbons anywhere, double bond is present? No. That's why I am writing AN, between carbons only, not between carbon and heteroatom. That is AN. Then it is end with AL. See, secondary suffix for aldehyde, AL. So now name is completely propanal. It is called propanal. Okay, so if I write carbon-carbon double bond, and if I write C double bond OH, now this is a carboxylic acid. Now see, there is no primary prefix, no secondary prefix, then see root word. So secondary prefix substitution is present. Okay, so that substitution in the form of double bond, that will be end with primary suffix only. So root word is 1, 2, 3, 3 carbons are present, I can say prop. Then what about primary suffix between 2 double bonds, 2 double bonded carbon? Here there is a orientation of double bond here, so I can write with En, then oic acid. Now what is the name? Propenoic acid. Propenoic acid, that is the one. If you know rules clearly, primary prefix, secondary prefix, root word, primary suffix, secondary suffix, you can understand clearly. Suppose see, if I take this example, now I want to explain primary prefix, secondary prefix, root word, primary suffix, secondary suffix. So ring is what? Cyclo. Now it is present. Now is there any secondary prefix, any substitution? No substitution. Now root word is hex. Between carbon-carbon double bond is present, so I can write ene, and it is hydrocarbon E. So what is the name of this molecule? Cyclohexene, like that. Automatically name will come if you know the 5 words clearly. So this is some examples regarding this. So you can understand clearly only when if you listen that 5 words of IUPAC nomenclature. Okay, so that is end of IUPAC nomenclature, 5 words. Okay, just make a short revision, then I will close the concept. So from first slide onwards I am explaining, just go through it. From starting onwards I am explaining. From where I started, where you need to focus, where you need to write key points, and how to revise, everything will be in one shot. See, nomenclature nothing but naming of organic molecule generally is nomenclature. There are two types, common and IUPAC name. Common name nothing but non-systematic, possible to give for many molecules, source name, trivial name, everything is possible here. Okay, so some examples are given like this: formic acid, acetic acid, propionic, butyric, urea, malic acid, citric acid, etc. Then I started directly IUPAC name. What is IUPAC name? International Union Pure and Applied Chemistry, where it is known as a systematic nomenclature. So due to rapid expansion of organic molecules, many molecules are introduced on that time. So that's why they want to follow some rules to identify the organic molecule. That's why they introduce IUPAC nomenclature in 1892, established in 1990. So everything is clear. Every molecule have its own IUPAC name, one word names. Then Geneva, Switzerland, there it is introduced. IUPAC is mixture of 5 words. You focus on this one only. Primary prefix, secondary prefix, root word and primary suffix and secondary suffix. Okay. Then directly go through this one. Primary prefix, explain about rings. Secondary prefix, there is no other alternative for secondary prefixes. Just concentrate the fragments and try to remember the name. So ఈ మాలిక్యూల్స్ అన్నీ కూడా మీరు నేమ్స్ గుర్తుపెట్టుకోవాలమ్మా. ఇక్కడ మీకు ఇలాంటి గ్రూప్స్ ఎక్కడ కనిపించినా సరే సెకండరీ ప్రిఫిక్సెస్ యూ ట్రై టు రిమెంబర్ దిస్ నేమ్స్: మిథైల్, ఇథైల్, ఐసోప్రొపైల్, టెర్షియర్ బ్యూటైల్, ఎక్సెట్రా. Right? So mostly when you write this CH2 with 2 single bonds, methylene, this is methylidine, like that. You need to remember these words. ఇవన్నీ కూడా మీరు గుర్తుపెట్టుకోవాలి. Once 1 or 2 classes, once if it is over, so you can remember and you can attempt very easily. సో స్టార్టింగ్లో మీకు ఏంటంటే కొంచెం ఈ మాలిక్యూల్స్ చూసేసరికి కొంచెం భయం వేస్తుంది, బట్ ఒక స్ట్రాటజిక్ రూల్స్తో మీరు ఫాలో అవుతే ఇట్ విల్ బి వెరీ ఈజీ. నో నీడ్ టు రివైజ్ వన్స్ అగైన్. ఓకే, ఎగ్జామినేషన్స్కి మీరు మళ్ళీ రివిజన్ చేసుకుని వెళ్ళాల్సిన అవసరం లేదు. డైరెక్ట్లీ బై వాచింగ్ దీస్ ఫ్రాగ్మెంట్స్, వన్స్ ఇఫ్ యూ ప్రాక్టీస్ ఇన్ మై క్లాస్, డెఫినెట్లీ యూ కెన్ అటెంప్ట్. ఓకే, దెన్ ఆల్ మాలిక్యూల్స్ ఆర్ గివెన్ స్టార్టింగ్ ఫ్రమ్ హాలోజన్, ఆల్కహాల్, థయాల్, సో ఆల్కాక్సీ, ఫార్మైల్, కీటో. యూ నీడ్ టు ప్రాక్టీస్ దిస్ వన్స్. ఒకసారి మీరు పేపర్ పైన అటెంప్ట్ చేసి, సో వితౌట్ వాచింగ్ దట్ ఫ్రాగ్మెంట్స్ యూ ట్రై టు రైట్. అదర్వైజ్ సో మీరు ఈ మాలిక్యూల్స్ ఆల్రెడీ లెఫ్ట్ సైడ్ రాశారు కదా, ఇవన్నీ మీరు క్లోజ్ చేసుకొని ఈ మాలిక్యూల్స్ని ఒకసారి రివైజ్ చేసుకోండి. మీన్స్ ఇలా క్లోజ్ చేసి వాట్ ఇస్ ద నేమ్, వాట్ ఇస్ ద నేమ్, లైక్ దట్ యూ కీప్ ప్రాక్టీసింగ్ ఇట్. అలా ప్రాక్టీస్ చేస్తేనే ఈ మాలిక్యూల్స్ గుర్తుంటాయమ్మా. అదర్వైజ్ ఇట్ విల్ డిసపియర్ ఫ్రమ్ యువర్ మైండ్. దెర్ ఇస్ అ కన్ఫ్యూజన్ బిట్వీన్ సెకండరీ ప్రిఫిక్సెస్ యాజ్ వెల్ యాజ్ సెకండరీ సఫిక్సెస్. సో సెకండరీ ప్రిఫిక్స్ ఈజ్ ఓవర్ with all these possibilities. Then root word explain, I explain up to 1000 carbons, but you better safe side you remember up to 100. సేఫ్ సైడ్ కోసం మీరు 100 వరకు గుర్తుపెట్టుకోండి. కీ పాయింట్స్ అప్ టు 20 వరకు మ్యాక్సిమం మీకు గుర్తుంటాయి ఈ కోర్స్. సో 30 అంటే ట్రై అకౌంట్, టెట్రా అకౌంట్, పెంటా అకౌంట్, హెక్సా అకౌంట్. సో 60 ఇంపార్టెంట్ కాబట్టి ఫ్యూ అదర్ నేమ్స్ ఆర్ గివెన్. 100 ఈజ్ నథింగ్ బట్ హెక్టేన్, 200 డోఎక్ట్, ట్రైఎక్ట్, ఎక్సెట్రా. ఓకే, దెన్ ఫైనలీ single bond, double bond, triple bond, saturate and saturate, primary suffix. Then secondary suffix, all functional groups I explain. Okay, so how to write names of organic molecule depends on this 5 words only. Okay, so once if 5 words are completed, then you are eligible to learn IUPAC nomenclature without any complete proper substitutions, because you need to know IUPAC rules. So కొన్ని examples నేను ఎలా తీసుకున్నానంటే, so that ఈ 5 rules or 5 terms, especially not rules, 5 terms in IUPAC, how to apply for a given molecule, that I explained clearly. Okay, so I think you understood the concept of IUPAC nomenclature first class. So in your next class I would like to explain complete IUPAC rules. IUPAC rules once okkari meeku clear ayyayi anukondi, then we will go how to write IUPAC nomenclature, and for individual functional groups as well as multiple functional groups. Multiple functional groups ki oka strategy manam follow avutama, means sequential order of some selective functional groups. Based on that we can select a parent child. Okay, so in your next class you will see how to give nomenclature with the help of a IUPAC rules. IUPAC rules చాలా ఇంపార్టెంట్. ఇంతవరకు మనం IUPAC rules చదవలేదు, ఓన్లీ IUPAC టర్మ్స్ మాత్రం మనం చదివాం. అంటే 5 టర్మ్స్ ఉంటాయి, ఆ టర్మ్స్ మనం ఎలా వాడాలి అంతే. సో నెక్స్ట్ క్లాస్ మీకు ఏంటంటే రూల్స్ ఉంటాయి. రూల్స్లో మీకు somewhat additional molecules are going to come and you can understand very easily. Okay, so we'll stop here and we will continue in your next class. Thank you.